Well, hi there. Today we're going to talk about multiplying algebraic terms. Multiplying algebraic terms is a little different than adding terms. Terms, remember, are either numbers or they're numbers with variables. And you can have a monomial term, which is just one term, binomial, which is two, trinomial is three, and then on from there. Let's be sure that we understand the differences between addition and subtraction of terms and multiplication of terms. If you're going to add or subtract terms, all you worry about is, do they have the same variable to the same power? This happens to be 2x to the first power. This is 7x to the first power. So we can just add 2 and 7 together and we end up with 9x to the first power. Below we have 10x to the first power and 3x to the first power. Same variables, same degree. So we take 10x minus 3x. 10 minus 3 is 7, so we end up with 7x to the first power. And that's basically what you do when you're adding or subtracting terms. However, when we multiply terms, we find answers with exponents, and we actually really start to work with monomials and binomials and trinomials. Now we're going to use the commutative property, and you'll find it just really goes slick. You have 2x times 4x, and if you look at it, you have 2 times x times 4 times x, because these are both multiplication in here, and they're multiplied times each other. So you can use the commutative property to move those around, because it's all multiplication. So you have 2 times 4, which is the 2 and the 4, and then you have x times x. Well, 2 times 4 is 8, and x to the first times x to the first is x to the second. And so we end up with 8x squared. That is a really pretty easy thing. And I'm going to show you a few more examples. And I do want all of these examples in your notes because they're all just a little bit different, and there'll be things that you'll run across. So be sure they get in your notes, and I'll be looking for them. Okay, here's the second example. 2x squared y times 3xy squared. Now, if we were trying to add these, we couldn't do it because this has a 2 and this doesn't. This has no, this is a x to the first and this is x to the third. There's no way we could add those, but we sure can multiply them, so don't let that get confused. Now again, we're going to use the commutative property because we can break all of this up because it's all multiplication. So we have 2 times 3, here's your 2, here's your 3. We have x to the second times x to the first, okay, that's actually a 1. And then we have y to the first times y to the third. Using the commutative property and associative property, here we go again. We have 2 times 3, which is, of course, 6. X to the 2 times x to the 1 is x to the 2 plus 1. Y to the first times y to the third is y to the 1 plus 3. We go ahead and do our addition, so we can do our, we're doing our multiplication of exponents. We end up with 6 times x to the third times y to the fourth. And now we can take out the multiplication symbols and just write it as 6x squared, 6x cubed y to the fourth. Okay? Now, example 3 is just a little different. It is negative 3ab times 1a cubed b squared times negative 2a times b cubed. Wow, a lot of different ones, and again, can't add them together at all. No way we could add those because they're all got different powers on their variables. So, the good thing we're multiplying, or they just stay exactly the same. Now, just a note, this 1 right here, it really doesn't have to be there. It could just be written as a cubed b squared. It wouldn't have to be there. Kind of makes it nice when you're multiplying, but it wouldn't have to be there. Okay? I'm going to use a commutative property again and reorganize these. Negative 3 times, there's that 1 down there, times negative 2. Then we have a, and this is a to the first, right? Times a to the third, times a to the first again. If it doesn't have a number, then it's automatically a to the first. Then we have b to the first, times b to the second, times b to the third. Okay? Now move this down a little bit. We're going to do some multiplying with our exponents, okay? 3 times 2 is 6, and it's a negative times a negative, which we're going to give you a positive, okay? So 6 times, and then you have a to the 1 plus 3 plus 1 times b to the 1 plus 2 plus 3, and you're going to add up those exponents, and you end up with 6a to the 5th times b to the 6th, and our final product is 6a to the 5th b to the 6th with the multiplication symbols removed. Okay? One more example for you, and this one I don't put the ones in because I want you to see one without the ones to start with. So this is negative xy squared times xy times 2y. Okay, now in our mind we're going to think that there's a 1 here and a 1 there. It'll just make our multiplication easier in our head. I'm rewriting it, so I rewrote it like this: negative 1 xy squared, 1 xy, 2y. Now I have a number in front of each one of those to multiply. So when I go to my next step and use the commutative property, I have negative 1 times 2, and that's these three. Then I have x to the first and x to the first, and then there's no x over here, so we're good with that, so these are both ones. And then I have y squared, y, and that's of course to the first, and then I have another y to the first, so these are both ones. Now we could do some combining here. Negative 1 times 1 is a negative 1, times 2 is a negative 2. So there is where that went. And we have x to the 1 plus 1 power, so that's where that went. And this is y to the 2 plus 1 plus 1, so that's where that went. We do our combining, we end up with negative 2 times x to the 2 times y to the 4, and we end up with negative 2x squared y to the 4th. Now, that wasn't too bad. Please be sure that you have all of the examples in your notes, because guess what? I will not sign the notes unless they're all there. So, I hope this was helpful. You have a great day, and I'll talk to you later.